This is a video about how I use arenas, but it's also directly responding to some ideas in another video. The video I'm responding to is Explicit Allocators Cause Function Coloring by Sam H. Smith. The link's in the description for the original video. Sam works on really cool stuff. The fact that I'm directly responding to his video and disagreeing with its thesis should not be taken as a sign of a personal beef or anything like that. Actually, the reason I decided to respond directly to it is because this video is really good. It perfectly articulates a problem that I also felt along the way when I was learning how I like to program with arenas. And I'm going to summarize the main points, but you should go watch his video for yourself if you want to fully understand this conversation. And by the way, Sam, thanks for putting this video out and letting me pick it apart like this.
In programming, there are two choices for you when it comes to manual memory management.
Okay, what are the two choices?
There's the old way of doing things with global allocators, aka malloc, and there's the new way, passing around explicit allocators.
Okay, now I'm going to skip ahead to see Sam's definition for those two options.
So let's define our terms first. By a global allocator, I of course mean something that is basically similar to a classical C malloc. Okay, I have this global thing, I can call a function, get some memory, I then do some stuff with the memory, and then I free it later by giving back the original pointer or whatever. You can have different schemes for this.
Okay, right. So global allocator means something like malloc, where the function is directly tied with a specific global allocation data structure. I follow so far.
The real modern technique is we want to use arena allocators. But a global allocator of this style, in the classic style, could never be an arena allocator because it has so many different users and they have completely overlapping lifetimes. You can make no assumptions, and so it definitely cannot be an arena.
Right. If the global allocator is being used in the same way that malloc generally gets used, then a global arena wouldn't work. The whole general heap type allocator is special because with that allocation data structure in particular, a global allocator can actually take you pretty far. You can almost get away with all the user code being written without regard to the existence of the other user code. If we switch to a global arena, suddenly all the usage code has to know about all the other usage code. And that's because with a single arena, lifetimes get tied together. You can only free memory in large batches. But I will say, global arenas do have a useful place in the way I use arenas. That doesn't negate what Sam has said. It's certainly correct that a global arena can't be a drop-in replacement for malloc and free.
Enter the explicit allocator. Here I have my function. It takes an allocator A. It allocates this integer. It assigns to it, and then it returns a pointer to that integer. And then, of course, the usage code we can see down here is we call my function, pass in the allocator we're using, and then when we free, we also specify that allocator.
Yeah, got it. So the difference with an explicit allocator is that the API takes the allocation data structure as an input parameter. What's really important here, though, is the API pattern of passing through the allocator. After all, we could just take an allocation API with an explicit parameter and totally subvert it by just making a global variable that contains our allocation data structure and then always using that in every location. Then we'd have something exactly equivalent to the global allocator. What's significant about the explicit allocators is that our APIs can be designed to take in parameters that control their memory allocation. In other words, explicit allocator parameters allow us to generalize our functions. With this pattern, we can describe how a task gets done independent from which specific allocation data structure is being used throughout the task. In contrast with global allocators, we end up coupling descriptions of how a task gets done to a specific allocation data structure. So it's not the allocation data structure itself or the API, it's the mutual design of layers conforming to one of these styles or the other one that we're actually comparing here. And by the way, this is still not the part where I'm going to disagree with Sam. He's also thinking in terms of the design of function APIs around these allocation systems. That gets especially clear when he starts talking about function coloring, but we haven't gotten to that part yet. So I'm just telling you up front that I don't think I'm disagreeing with Sam here. So let's keep going.
We can change it to be an arena. Okay, so we pass in an arena, and an arena is just a type of you can think of it as a type of allocator that where you allocate a bunch of times and then you free once. You free basically everything you allocated in a certain period. And now our usage improves from this because we now get rid of this free call. We can, use the arena, and then we reset it at some later point. Now, some people will say that like the reason you want an arena is because of speed, and that's certainly true. But the real reason, I think, is for productivity, is that it actually tremendously simplifies the amount of effort you spend allocating memory. Because before, like I said, like on the global allocators, you can just call malloc from everywhere, and you can be tremendously productive when you don't have to remember to free. Well, the advantage here is we actually don't have to remember to free. Your functions can just emit memory like it's spray, like it's sawdust, right? It just, you just alloc. It does not matter because we don't need to remember to free it. That's the advantage here, is we can just, we can just be absolutely careless with our allocations, and then, because it'll get freed later at some point.
Great. To me, this is why we really have to think about explicit allocator parameters at all. The fact that arenas are so darn good makes us want to use them, but they just don't work as well with the malloc and freestyle global allocator, and they work a lot better when used in this pattern of explicit allocator parameters. So it's arenas more than anything else that are pushing us to think more about explicitly passed allocators. Now, time to hear Sam's ideas about the problem with explicit allocators.
But this has problems, this explicit approach. This applies both to the arenas but also the explicit allocators, which is, here we have procedure A, procedure B, procedure C, okay? And there seem to be no issues here, except that B can only call itself, whilst A and C can call all the procedures.
Okay, this is where the disagreement does begin. The way I work with these systems, procedure B can call procedure A and procedure C. But I think I understand why Sam is saying this. We're not using global allocators, right? So the only allocators function can use are the ones that are passed into it. Proc B doesn't have any allocators passed into it. Therefore, proc B cannot use any allocators. In order to use proc A or proc C, you need to have an allocator, and therefore proc B can't use proc A or proc C. So where I disagree with that chain of reasoning is right at the beginning. The fact that we are using explicit allocator parameters doesn't mean we're not using global allocators. We can actually do both, which means proc B can just use a global arena variable to call proc A or proc C. Or there's another flavor of the same approach. We can let proc B call proc A or proc C if we can construct arenas out of thin air. If proc B can construct an arena out of thin air, then it can call proc A with the arena it constructed. And of course, the ability to construct arenas out of thin air is very malloc-like. Under the hood, that would also rely on some kind of global allocator. But it's another flavor of the same idea. Are we going to say we can't construct arenas anywhere in the code? Because if we're going to say that, then it would make sense to say proc B can't call these things. But if we're being literal, why can't proc B construct an arena to call proc A or proc C? Now you might be thinking, hey, Alan, the whole point is that I don't want to rely on global allocators. I want to minimize that and eliminate it everywhere that I can. And if you're thinking that, I mostly sympathize. All I'm trying to do with the examples I've given so far is to punch a crude hole in the assumption that procedure B wouldn't be able to call procedure A or procedure C. It would take more concrete examples and more methods of retrieving arenas from other systems to actually make a predictable and orderly system, but the point is the idea that proc B can't call proc A or proc C is a wrong assumption, and it's easy to see that that's a wrong assumption just using very crude methods. Now, the rest of Sam's idea is going to be built on top of this assumption that procedure B can't call procedure A or procedure C. So I'm going to continue to disagree with the rest of what Sam has to say built on top of this. But it's still going to be useful to play out the rest of the idea because Sam brings up a lot of interesting points and examples along the way.
What we've introduced by having these explicit allocators or explicit arenas is we've introduced a function coloring. This becomes a terrible drag on productivity. You waste so much time because it seems fine for the moment until you need to, because you're always changing the code. That's the secret. Is you're changing the code. You realize proc B needs to call proc C, but it's red, and so it can't call into blue. We get this. This is the fundamental coloring problem, right? Blue can call red, but red cannot call blue. And for our allocators, this isn't for async, it's just two colors. For our explicit allocators, this actually grows with the amount of allocators.
Okay, this part is interesting too, and it does 100% correspond to a real issue that comes up with explicit allocators. I think a concrete example is going to help here. Let's say you're writing a parser for a textual file format. You're going to have some input text file and a grammar that you're using to find structure within the text file. As it runs, the parser is going to be allocating nodes and arranging them into a tree, but it's also going to be doing some other stuff. It's going to be emitting some kind of user-facing messages like errors and warnings, and since you're in the middle of developing all of this, it's also probably going to be emitting something like developer diagnostics. Now, depending on exactly where you're calling this function and what you're going to do with the data, it may end up being more convenient to have each of those different types of allocations going into its own arena. For example, the tree might be a temporary that's going to be consumed by another stage in your transformation pipeline. The messages might get attached to the lifetime of some kind of user-facing UI element, and the developer diagnostics might go to some never-freed, only growing log data structure. Even though there are lots of allocation parameters here, this isn't going to be hard to call. Well, I mean, syntactically, it is sort of hard to call. It is a little bit like a big thing to bundle up all that information, but it's not the case that the function that calls this parse function itself needs to have 3 arena parameters in order to qualify for calling it. The answer is that we need to be able to do 3 separate things. 1, we need to get our hands on an arena for temporary data. 2, we need to get our hands on an arena that corresponds to the user-facing UI element that's in this interaction. 3, we need to get our hands on a globally unique developer diagnostics arena. Now notice, we can solve all of those without necessarily needing a pass-through arena. The temporary arena could be constructed locally. The arena that corresponds to a UI element could be retrieved through some kind of ID keying system. And the developer diagnostics arena could be, just a global arena. Of course, any of them could also be pass-throughs too. It depends on the structure of the specific calling code that's being written. Hopefully, with an example like this, you can begin to see that the power of arena parameters isn't in passing arenas through the call stack. The power is in being able to organize allocations at each call site.
We have 0, 1, 2, 3, red, blue, green, orange procedures. And orange can call all these things. Green can call green, blue, red. Red can only call red. But we can solve this problem if we recognize that most of the time is spent writing red and blue procedures. Green definitely occurs, orange occurs as well. Those tend to be more in a certain subsystem, or you have some system that you're designing where you need to care more about stuff. But a lot of the code we just want to just write this, reuse it later, whatever, is red and blue. And certainly red is what we write by default, right? So what we can do is if we just turn the red into blue, we force color it blue, we stop having these function coloring problems. So to make this practical, in this original example, we just force ourselves to always put an arena argument, even if the procedure doesn't allocate. Well, it doesn't allocate currently, but it may allocate sometime in the future after a refactor. Well, now we're just typing a bunch, right? So, okay, we got rid of the coloring, we've gained in productivity. procedure B is now exactly like procedure A, procedure C. We don't have this coloring problem. This is what I see with many friends of mine who use the explicit allocator approach, is that they just do this. They get into the habit of always typing out the arena parameters, and then they pass it throughout their entire code base. Always passing around this arena parameter. Well, what we can do is, if we have the programming language on our side, we can just say, oh, if every procedure by rule is going to have this arena parameter, we just get rid of that. We introduce a context struct. So a context is basically, you can think of it like thread local storage, but it's implemented in the language. So you always have access to this context. Then we get rid of the arena parameter because we always have access to the context. And then we just use the arena that's on the context in all these cases. Now what happens here is we can now say context arena is arena 1. We call procedures A, B, C, and then we reset arena 1, right? And all the things that happened in between here, all the allocations get freed. And procedure A, B, and C all used arena 1.
Yeah, okay. Sam, now I'm talking directly to you. I don't think you want to do this. The whole advantage to explicit allocator parameters is that they put useful information right into the function signature. And that leads to two immediate benefits. One, when we're reading the code that defines an API, we can immediately determine which functions return allocated memory, because those are the ones that take in an arena parameter. And two, when we're reading code that calls out to functions that make allocations, we can immediately identify where each allocation is taking place in the code, and on top of that, we can see which arena is getting each allocation, right in the same line as the call itself. Now, you've correctly pointed out that occasionally code changes. Procedure B used to not call procedure C, and now it needs to. However, there's another question. Does procedure B use procedure C for temporary intermediate computations, or does procedure B now allocate memory as a side effect because of its call to procedure C? If procedure B is just using procedure C to compute an internal temporary, the signature of procedure B doesn't need to change. You just need some way to get your hands on a temporary arena implicitly without having to pass it through. But if procedure B does need to allocate memory as a side effect, then reflecting that change in the signature seems very appropriate to me. All the locations that previously called procedure B believed it did not allocate, and so if it's going to start allocating, all those call sites now need to make a new decision about how to organize procedure B's allocations. In the system you've described, I would expect a type of refactoring bug to emerge, where anytime a function that I have transitions from not allocating to allocating, it could quietly pick up inappropriate allocation parameters in some locations. And if that bug does start emerging, the way I would have to fix it would be to track down every call site, figure out for each one if the intent of the call site matched whatever was implicitly in the context, which also involves figuring out what's in the context, which could be quite a few number of lines away from the original call site. And of course, I'm going to have to do the same work if I make it explicit, but at least when it's explicit, after I've decided whether to use one arena or another for that particular call, I will have explicitly marked it, whereas when it's implicit, all the places where I didn't make progress look exactly the same as all the places where I didn't actually make a decision explicitly. So I can never really remember for sure that I've finished the transition by writing something into the code. Okay, I think that's all that I want to cover for today. To summarize, I don't like this idea that using explicit allocation parameters disallows retrieving allocators from other sources. Global arenas constructed from thin air, and other subtler options like thread locals, and arenas attached to data structures that are more complex, these all are perfectly valid and useful tools in addition to explicit allocation parameters. And when a function takes in an arena, that doesn't color the function. It generalizes the function's allocations. That's all it does. An allocation parameter means that the function is saying, hey, I am willing to send my allocations wherever the caller would like me to send them, but I need the caller to tell me where. Now, while I can see how making this parameter explicit at every call site could feel like a drain on productivity, after getting used to it, I believe it is far superior for long-term productivity than any method that would make the allocator parameter implicit. That's the end of the video. Thanks for watching. If you would be so kind, a like and a subscribe would be hugely appreciated. And if you like the projects I'm working on here, maybe consider supporting. All my projects are counting on support from viewers like you. And did you know that supporters are getting videos like these a week early now? Check out other perks at mrforth.com/membership. And with that, I'll see you next time. Bye.